Hey guys, it's Miss Johnson and I'm here to bring you our fifth and final notes video for Unit 2. Today we're talking about solving systems using any method. More specifically, we're talking about how do we decide when to use substitution and when to use elimination. So we've got these two methods of solving systems, but how do we know when to pick each one? So, for substitution, we use substitution when we have a variable that's by itself. We have an equation that's solved for one of the variables. When we have equations that are in slope-intercept form, or when we have equations that it's easy to get one of the variables alone. Okay. We use elimination when we have equations in standard form, when we have equations that have opposite signs, or when we have equations that have the same number on the same variable. Okay, so we're just going to take a look at some examples of how we choose how to solve it. So if I look at number 1, I have 3x minus 5y is equal to 7 and 2x plus 5y is equal to 13. Now the first thing I recognize is the fact that both of my equations are written in standard form. The x terms are lined up, the y terms are lined up, the equal signs are lined up, and the constants are lined up on the other side. So I naturally am going to choose elimination because they're already set up for that nicely. Then the next thing that I recognize is the fact that my y terms have opposite coefficients right here. This one is a -5, this one is a +5. So I don't even have to multiply by anything. I'm already set to add these together because when I do that, my y terms are going to drop out and that will leave me with just an x that I can solve for. So 3x plus 2x gives me 5x, and 7 plus 13 gives me 20, and then dividing both sides by 5, I end up with x is equal to 4. I need to plug that back in and get the y value. I'll just use the top equation. It looks like 3 times 4 minus 5y is equal to 7. 3 times 4 gives me 12, so 12 minus 5y is equal to 7. I'm going to subtract 12 from both sides. That leaves me with -5y is equal to -5. Don't forget to bring that negative with the 5 once the 12s go away. It's still there. And then I need to divide both sides by -5. And that leaves me with y is equal to +1. So I have a solution here of 4 comma 1. That is where these two equations meet. All right, so let's look at number 2. Oh, and by the way, we can mark this here. I used elimination in number 1. If I look at number 2, now I have 5x plus 3y is equal to 3, and then the bottom equation looks like y equals 2x minus 10. Now the fact that I have that y equals right there tells me that I have a variable alone. Y has nothing else with it. So I can very easily use substitution and take that phrase that's equal to y and plug it in for y up above. So I'm using substitution here. When I do that, it looks like this. The 5x doesn't change. Then I have plus 3 times that quantity that's down below, 2x minus 10, and the whole thing is still equal to 3. Now I have one equation with one variable, and I can solve that. So I'm going to distribute the 3 into both parts. That leaves me with 5x plus 6x minus 30 is equal to 3. 5x plus 6x are like terms. I'm going to put them together. 11x minus 30 equals 3. And then add the 30 to both sides. And I have 11x equals 33. Almost done. X is equal to 3. Okay, so then I need to plug that back in and get the other variable. I need to get the y value. Now I'm going to choose to use this bottom equation because y is already by itself down there. So it's easy to simplify the right-hand side. So I have y is equal to 2 times the 3 that I found already minus 10. So that's y equals 6 minus 10. That's y equals -4. So my solution looks like this, 3 comma -4. All right, let's take a look at number 3. In number 3, I have y plus 3x is equal to 24, and I have 5x minus y is equal to 8. No, I don't have a variable alone in either equation, but I do have variables that I can very easily get alone. So, but I can also very easily switch the order of this x and y term in the top and set it up for elimination. You can do either. I think most people like elimination better, so that's what I'm going to do. I'm going to use elimination. And I'm just going to line up my variables and see what that does for me. So in this top equation, I need to switch the order of the x term and the y term. So it's going to look like 3x plus y is equal to 24. Then in the bottom equation is going to stay the same. 5x minus y is equal to 8. Now, that was really helpful because now I notice that my y terms have opposite coefficients. Here's a positive one and a negative one. So I'm already set to add these together. I add them together, my y terms go away. 3x and 5x is 8x, and 24 plus 8 gives me 32. Then I divide both sides by 8, and I have x is equal to 4. So now I need to plug that back in and get the other variable. When I do that, it looks like y plus 3 times 4 is equal to 24. That's y plus 12 is equal to 24. Subtract the 12, and I have y is equal to 12. 24 minus 12 is 12. So my solution here looks like 4 comma 12. All right, let's take a look at number 4. In number 4, I have 5x plus 3y is equal to 16. 3x minus 5y is equal to negative 4. I do not have opposite coefficients in this, but I do have equations in standard form. X terms lined up, y terms lined up, equal signs lined up, constants lined up. So I am going to use elimination again, and that just means I have to multiply both equations by something. I'm going to focus on the y's here because I notice that this top y variable is positive and the bottom y variable is negative. So if I want to cancel these, I need to multiply the top one by 5 and the bottom one by 3 so that they go to 15 and negative 15. So top equation gets multiplied by 5, bottom equation gets multiplied by 3. And let's take a look what that does to our two equations. For the top equation, I'm going to have 25x plus 15y is equal to 5 times 16, which is 80. The bottom equation, I'm going to have 9x minus 15y, and there's that opposite coefficient that I wanted, is equal to negative 12. So then I have to add these two equations together. And when I do that, I end up with, sorry, that line was bad again. I end up with 25 plus 9, which is 34x. The y terms drop out, and 80 minus 12 is 70, no, sorry, 68. Where's my eraser? There it is. 68 there. Dividing both sides by 34, I end up with x equaling 2. So now let's plug that back into one of our original equations and find the y value. So I have 5 times 2 plus 3y is equal to 16. That's 10 plus 3y is equal to 16. Subtract the 10. 3y is equal to 6 and divide by 3. I get y is equal to 2. So the solution to this equation is 2 comma 2. Okay, a couple more practice questions like this. In number 5, I notice that I have a y equals. Right away, my eye is drawn to that y equals. So that tells me already that I'm going to set up substitution here. So I'm going to take that phrase that y is equal to, and I'm going to plug it into y down in the other equation. So that looks like this, 3x minus 2 times that whole quantity up above, 4x plus 11 is equal to negative 7. Now I distribute that. I get 3x minus 8x minus 22 is equal to negative 7. And then 3x minus 8x is negative 5x. Add the negative 22 to both sides, or add 22 to both sides. So negative 5x is equal to positive 15. And then divide by negative 5, and I have x is equal to negative 3. So then at that point, I plug it back in to get the y value. I'm going to use that top equation since y is already alone. So y is equal to 4 times negative 3 plus 11. That's y equals negative 12 plus 11. That's y equals negative 1. So I have negative 3 comma negative 1 for my solution. One more practice question like this and then just a couple of word problems and we'll be done. So number 6, I have 4x plus 3y is equal to 19 and 3x minus 4y is equal to 8. I don't have opposite coefficients anywhere, but I do have coefficient or like terms lined up. X terms lined up, y terms lined up, equal signs, constant. They're both in standard form, so that helps me a lot. I'm going to choose to use elimination in this question, and I will go from there. So let's take a look at our two scenarios here. I need to cancel out one of my variables. I notice that my y terms have one positive and one negative, so I'm going to focus on those. I would need to get them both to be a 12 coefficient. So I'm going to multiply the top one by 4 and the bottom one by 3. And that's going to give me a positive 12 and a negative 12, which then they'll cancel out. So let's rewrite those two equations. Distributing the top one gives me 16x plus 12y is equal to 76. Distributing the bottom one, I get 9x minus 12y is equal to 24. Adding those two up, my y terms drop out. 16x and 9x is 25x, and 76 and 24 is 100. Dividing by 25, I get x is equal to 4. Plug that back in. I'll use the top equation. It looks like 4 times 4 plus 3y is equal to 19. That's 16 plus 3y equals 19. Subtract the 16. That's 3y is equal to 3. And divide both sides by 3. I'm running out of room there. When I divide both sides by 3, I end up with y is equal to 1. So now looking at the answer to this, our solution is at the point 4, comma 1. All right, two word problems left. Number 7, it says Deshawn and Shayna are selling flower bulbs for a school fundraiser. Customers can buy bags of windflower bulbs and bags of daffodil bulbs. Deshawn sold 10 bags of windflower bulbs and 12 bags of daffodil bulbs for a total of $380. Shayna sold 6 bags of windflower bulbs and 8 bags of daffodil bulbs for a total of $244. What is the cost of each bag of windflower bulbs and each bag of daffodil bulbs? Okay, so again, we're given a situation here where we don't have a system set up. So we need to write that system and then solve it. The first thing I want to do, the first thing that you have to tackle is what are you trying to find? So what is the cost of one bag of windflower bulbs and one bag of daffodil bulbs? So that's what I'm going to name my variables. I'm going to say that X is windflower and Y is daffodil. Now I can look at the two people, Deshawn and Shayna, and I can write an equation for each one of them. If I look at Deshawn, it says he sold 10 bags of windflower bulbs and 12 bags of daffodil bulbs for $380. So that's 10 times each X plus 12 times each Y is equal to $380. Then if I look at Shayna, it says that she sold 6 bags of windflower bulbs and 8 bags of daffodil bulbs for $244. So that's what Shayna's equation looks like. Now I need to solve these two. So here's the system that I have, and now I need to solve them. This system is set up really nicely for us to use elimination. I have x, y's, equal signs, and constants all lined up. So I'm going to go ahead and eliminate. But I don't have opposite coefficients anywhere. So I have to multiply both equations by something in order to get opposite coefficients. Now there's lots of ways that you can do this, but I think the easiest way of doing this is just by picking one of the variables and doing the other coefficient's number. So I'm going to choose x and eliminate x. I'm going to multiply the top equation by 6 and the bottom equation by negative 10. Notice that one is positive and one is negative, so that'll give me a positive 60 and a negative 60, and they'll cancel out. So let's rewrite those equations after I do the multiplication. That means I have 60x plus 72y is equal to 2,280. This is where it's really good to have your calculator out if you don't have it out already, especially with these big numbers. And you can check as you go to make sure you're getting the same thing that I'm getting. So if I distribute the negative 2 in the bottom equation, negative 2 times 6 is negative 60. Negative 10, I'm sorry, not negative 2, negative 10. Negative 10 times 8 is negative 80. And negative 10 times 244 is negative 2,440. Opposite coefficients, add them up. So the x terms drop out. 72 minus 80 gives me a negative 8y. And 2,280 minus 2,440 gives me a negative 160. So then I divide both sides by negative 8, and I end up with y equaling 20. So that means that each bag of daffodil bulbs is $20. Now I got to plug that back in and find the windflower bulbs. I'm just going to use the top original equation and plug it in. I'll have 10x plus 12 times 20. Now I know that y value. 12 times 20 is equal to 380. 10x, multiply those two together, I get 240 equals 380. Subtract the 240, and I end up with 10x is equal to 380 minus 240 is 140. And then divide both sides by 10, and I get x is equal to 14. So that tells me that the windflower bulbs are $14, and that the daffodil bulbs are $20. So that's how I can write out my solution, and I'm good there. Let's do our last question for Unit 2, Notes 5. I'm looking at number 8. It says at a store, toothbrushes cost X dollars and bars of soap cost Y dollars. One customer bought 2 toothbrushes and 1 bar of soap for $11. Another customer bought 6 toothbrushes and 5 bars of soap for $38. Both amounts do not include tax. How much did each toothbrush and bar of soap cost? So again, the first thing that you want to identify is what are you trying to find? How much did each toothbrush and bar of soap cost? So I'm going to call my toothbrushes X and my bars of soap Y. Now I have an equation for each customer. It says one customer bought 2 toothbrushes, that's 2 times X, and 1 bar of soap, so that's 1 times Y, for $11. Another customer bought 6 toothbrushes and 5 bars of soap for $38. Okay, again, this is set up really nicely to use elimination. I have x's, y's, equal signs, and constants all lined up. I don't have opposite coefficients, but I see a place where I can very easily get opposite coefficients. If I take this top equation and I multiply it by negative 5, that's going to give me a negative 5y, which drops my y terms out, allowing me to solve for x. So that's what I'm going to do. Distribute a negative 5 all the way through. That gives me negative 10x minus 5y is equal to negative 55. So now I'm done with this top equation. I'm going to add up the bottom two that I have and see what I get. 6x minus 10x is negative 4x. The y terms drop out because one's positive 5, one's negative 5. And then 38 minus 55 gives me a negative 17. Divide both sides by negative 4, and I end up with x equaling $4.25. So that tells me that each toothbrush is $4.25. Then I got to plug it back in and find the cost of the bars of soap. I'll just use that original top equation. I have 2 times 425 plus 1y is equal to 11. 2 times 425 is 850 plus y is equal to 11. We don't need to write that 1. It doesn't make any difference there. So subtract the 850. And then I have y is equal to $2.50. So when I write this out as a solution, I have toothbrushes costing $4.25 and bars of soap costing $2.50. All right, this concludes our notes video for today, Unit 2, Notes 5, Solving Systems Using Any Method. Don't forget to check your notes sheet off with Ms. Johnson, and I will see you later. Thanks for tuning in.